Hello, we are continuing on my series of using a Chromebook running Fusion 360 to create the CAM of a machine profile of the state of Indiana. We will ultimately use a Haas Mini Mill to create the part. This video will describe the steps of creating the tool paths in CAM. So the first thing we want to do, I like to put this part in the way it will be when we actually machine it. So when it's sitting in my machine, this is my point of view reference to this part. So the first thing I want to do is I want to create a face. So I come up here to face. When I create the facing profile, I am going to just go through each of these tabs. Now, these tabs contain a lot of information. I am mostly just going to go through the items that are needed to create this face. But I want you to notice that as you hover over each item, it will tell you what it does. And it'll help out quite a bit if you do get a little bit lost. So first things first, we need to select a tool. Now I already know in my mill, I want a mill, I want a flat end mill. I have a 1/2 inch flat end mill right there. I'm going to choose aluminum roughing, but you'll see we're going to change that in just a minute. Aluminum roughing is great, but my mill has a maximum RPM of 6,000. So I need to go through and modify this. So I'm going to come up, right click, edit tool. And now I'm going to edit this tool for my situation. So if you go through, we've got general, cutter, right, flat end mill, it's in inches. I only have 2 flutes on this end mill that I plan on using. Shaft, holder, cutting data. So again, like I said earlier, I have a maximum of 6,000 RPMs. As you change this, you'll see this will change our inches per minute. Now the other thing, I know for my situation, I need to keep it about 2,000 inches per minute feed per tooth. You'll see that'll drop me to 24 inches per minute. I'm going to drop the rest of these to 24 inches a minute. Use step down, I'm good with that, and I'm good with the step over of 0.5. I will not be using coolant for this, so no coolant, accept the changes, select, and you can see all my changes have transferred over. So now that I've selected my tool, next thing I'm going to select my geometry. You'll notice the geometry didn't select exactly like I wanted. It's all right, that happens a lot. We come back here, we right click on tool, we edit it. Come back to geometry. We'll clear the selection. Now, this should be what I'm expecting in my face. My heights. I have some selections here. I'm not going to get into them real in depth except where my bottom of my end mill, I want that actually to be a little bit into my work. This one is here dealing with my passes and linking. Again, this is supposed to be a quick video, so we will not be going into that in too much detail. But I now have my facing. So I want to do a simulation. It's going to show me what it should look like. I'll speed that up a little. Gives me some statistics. I'm looking at 2.5 minutes to do that facing. Notice because I chose my bottom depth to be 10 thousandths under my surface, it actually shows me going through the part a little bit. And for what I'm doing, I'm perfectly fine with that. Okay, now we've faced. Let's get into some 2D. All right, I'm going to do some adaptive clearing here. Note, I'm going to stay with tool number 1. Actually, I did make a mistake there. It should be tool number 6. We'll edit that, come back in, edit tool, post-process, accept, select, and please note, tool locations on our Haas Mini Mill are located next on the wall, and speeds and feeds for our tooling are also located on that wall. Geometry, pocket selected, none. So I selected the geometry. It figured out what the stock was. Bottom height. I'm going to come in and select model bottom. Now, if I'm curious what that looks like, I can flip this up on end and see that it is going to machine down to the bottom. Now, your retract height, clearance height, those are how much the tool is going to pull up before it moves around. All right, I did pick up an error. It's telling me that I'm going to end up with a little bit of stock in between each row, so we'll try to smooth it out. Great, that's what I'm looking for. One last thing, I would like to get a little bit closer on this where the Ohio River runs in the Wasatch. And so I'm going to pick one more tool. Same operation, adaptive clearing. Now though, I'm going to pick milling again, flat end mill. I'm going to pick 1/8 of an inch flat end mill. You can see my RPMs are too much, so I'll come back in and edit that tool. Edit tool, 1/8 inch, yep. Inches, I only have 2 flutes. Shaft, holder, just go through one by one. All right, so now max 6,000 RPMs. You look up on the wall, 0005. is the number of inches per minute that this tool should be traveling, which gives us is the number of feet per tooth this tool should be traveling, which equals 6 inches a minute. Again, turn off the coolant for our operation. And this tool is in spot number 2. Accept. Okay, so pocket selected. Now on this one, we are going to go through and look at these. So reset machining, tool diameter, 1/4 inch. So if we go ahead make that 1/8 of an inch, it'll only machine what was missed by the 1/2 inch tool. 1/2 inch, not 1/8 inch. Again, we want model bottom. Let's see if I did that right. Oh, we can fix that. See if it's happier with that. Great. And as you can see, that 1/8 inch tool comes in and just gets a little bit closer to the bottom of Indiana as it runs along the river. Okay, so close. Now I'd like to see all 3 tools run, so I'll click on Setup. I'll hit Simulate, Play. You can see our facing operation, our rough cut, and then our fine cut right along the rivers there. All right, thank you very much. Happy cutting.